So, hey, good evening, everyone. My name is Shiva Mishra, and I welcome you all in this third and last speaker session of the 1 week long Abhiyuthhan event. Today with us is Lentin Joseph, sir. He is founder, CEO, and Senior Robotics Software Engineer in Qbotics Lab. Apart from that, he is owner of Robocademy, and he is a senior ROS and robotics software consultant, being an author of 8 ROS book. And apart from that, he is a TEDx speaker as well. So let's introduce Lentin Joseph sir to the audience. So Lentin Joseph sir, you can take over from here.
Yeah, sure. Thanks for the introduction. So I think we can start. Okay. Today's topic is introduction to robot operating system, and so what I will do is that I will give you a brief idea about the robot operating system. Okay. I'm not sure how many of you work in this framework, but in this span of time, I can try to give you a brief idea of this framework. Okay, so I prepared my bio in the slide itself, so I will just go through my portfolio. Actually, I'm working in ROS for maybe last 10 years, and I have a company called Qbotics Labs. So we are actually doing the consultancy in robotic software development using ROS. Okay, and I'm also maintaining a blog called Robocademy, mainly sharing the things related to ROS, robotics, etc. And I used to write books in ROS. Till now, I think I have written 8 books in ROS, and all books are available in Amazon. Also, I have worked in CMURI for a while, and I have taken masters in robotics and automation, and I have done a TEDx speech also. So this is about myself. I'm mainly into robotic software development, and these are some of the books you can see. There are beginners books like Robot Operating System for Absolute Beginners, then Learning Robotics Using Python. So I'm just going through the titles. These are some of the books that I reviewed. So most of the books that I'm reviewing is also related to robotics and embedded system. Okay, yeah. So this is agenda for the today's sessions. So because of the lack of time, I'm just going through the abstract idea. I mean, I'm trying to give an abstract idea about ROS. Okay, because this is a very big subject, and currently I'm actually running a course that is, the course duration is like 1 year. Okay, a ROS course. So you can imagine the magnitude of this topic. So we are trying to. I'm trying to just give an idea about ROS within a span of 1 hour. Okay, so I will quickly go through the basic concepts. Okay, then we can see some demos at the end. Okay, so if you have any doubts, you can just put it in the chat. Okay, so I will be starting with the basics robot and robot programming. Okay, I will quickly go through it. Okay, then we will see the robot programming approaches, again a simple topic. Then we will start with ROS. Okay, so in the meantime, before starting with the ROS, I will also explain some of my experience, when I start working with ROS, what were the difficulty, or before ROS, before using ROS, what were the difficulty, those kind of stuff. Okay, so we can quickly go through it. Okay, so let's start with the robot and robot programming. Okay, so I think you may be aware of the fundamental blocks of a robot. Okay, it's like sense, think, act. Okay, the robot is having sensors for perceiving the world, and it is having a brain. That is a think part. It can be a computer, microcontroller. So the main use of the think part is the processing the data from the sensors. Okay, and after processing the data from the sensors, it is controlling the actuators. That is the act part. Okay, so in the actuator part, we can include many actuators like DC motors, stepper motors, then servo motors, those kind of stuff. Okay, so this is the basic block diagram of any robots. Okay, and this is a robot feedback loop. Basically, there will be a brain in the robot. So it is actually taking the sensor reading, processing it, and sending the control signals to the robot. Okay, so in the robot there will be actuators, and that will be controlled by the control computer. Okay, so this is a basic things, and this is the basic loop, sense, think, act loop in any robot. You can see like the robot is sensing, then it's feeding to the computer, then the computer is controlling the actuators, and these loops keep on running. Okay, so this is an expanded view of a robot. Like again, it's a simple one. You can see, let me switch to the highlighter. Yeah, oh sorry, maybe laser point will be fine. Yeah, so in the think part you can see a microcontroller, a computer, or a single board computer like Raspberry Pi. So that's all belongs to the think part. And in the actuator we can see different kind of actuators. You can use any actuators in a robot. Then the sense, you can maybe different kind of sensor like vision sensors like camera, depth camera, lidar, then ultrasonic sensor. Those kind of things will be belongs to the sense part. Okay, so these are some of the popular sensors, actuators, and computers. So in the sensors you can find like camera is a vision sensor, wheel encoders, it is actually for computing the velocity of the wheels, then ultrasonic sensor for finding the distance, then actuators, you can use servo, stepper, DC motors. I mean, there are a list of actuators available in the market. Then the computers, mostly the robot uses portable computers like or miniature computers like Raspberry Pi. It's actually a small single board computer, right? And you maybe heard about the Intel NUC, then NVIDIA TX2. I will show that. I will show in the next slide. Also, you can use the microcontrollers board like Arduino, then a Launchpad, then a TNC. These all belongs to the think part, or we can use it for the compute. So these are some of the actuators that we are commonly using: RC servos, stepper motors, gear motors. I'm not sure you have heard about the dynamic cell smart actuators. This is pretty expensive, but we can use it for many purpose. Okay, and there is industrial servo motors that is mainly using for the industrial robotic application. Okay, so these are some of the popular sensors. I mean, I just included like Velodyne. This is the sensor that we are using in the self-driving cars. Then you maybe heard about Kinect, depth, Intel RealSense. These are the depth sensors which can be used for the autonomous robots. Okay, so I think you may be familiar with these ultrasonic sensors, sharp distance sensors, laser scanner, and all. Okay, and these are the compute units that we are using. Raspberry Pi may be familiar to you, and Intel NUC is a miniature desktop computer, and we can use it inside a robot. Then NVIDIA TX2 is again a supercomputer for robots. So these are the compute units that we are using, I mean commonly using in a robot. So next we are jumping into robot programming. What is robot programming? It's again very simple. Like we have seen the sense, think, act loop, right? So basically in the think part, what we are doing is we are modeling the behavior of the robot. Okay, we are getting the sensor value from the sensors, and the think part is having a computer, okay, a compute unit. So the compute unit is actually modeling the behavior. Okay, so imagine that is a black box, and the input to that black box is the sensor values. Okay, and the output is the actuators, control commands for the actuators. Okay, so we are basically modeling the behavior of the robot using a programming language. That is actually the robot programming. You can use any programming language. Commonly we are using C++, Python, C, etc. So this is actually the robot programming in a simple words. Okay, so commonly we are using C++, Python for modeling the behavior of the robot. Okay, so that is robot programming, and there are two approaches for programming a robot. Okay, so basically programming is a software, a software job, right? So either you can use some existing framework to program, okay, like some existing framework, and we can reuse it. Okay, and the next method is like we are not using existing framework. We are just using the programming language and we are implementing everything from scratch. Okay, so we are focusing on the first thing. We are actually using some existing framework and we are programming robots. Okay, so that is actually mentioning in this session. The second one is like we are implementing everything from scratch. So this method I will prefer in a product development. Okay, because in the second method we will have more control on the software. Okay, in the first method, like we are using some existing stuff and we are developing our application on the top of the existing framework, right? So we will not have full control. Okay, but we can quickly prototype the idea. Okay, so robot operating system is an existing software framework in order to program a robot. Okay, and you maybe also heard about the Arduino framework, right? It's also an existing framework for programming robots. Basically, we can program the Arduino microcontroller, and if we can put that microcontroller inside a robot, again, it will act as the think part of the robot, right? So we will be talking about the robot operating system, that is an existing software framework to program a robot. Okay. Okay, so these are some of the famous programming frameworks available in order to program robots. Okay, a robot operating system. It's actually a communication middleware. Okay, I will explain detail in the upcoming slide. So it's not a real operating system. Okay, as a name says, I mean, the expansion is robot operating system, right? But it's not an operating system. But the main functionality of ROS is communication middleware. I mean, it will act as a communication middleware, meaning if you have two programs, and if it is running on a computer, these programs can communicate with each other with the help of ROS. Okay, so that is the main purpose of ROS. Okay, so we will see why we use communication for robot programming. Okay, in the upcoming slide, and maybe you have heard about the OpenCV, open source computer vision. That is for the computer vision related application in a robot. Again, we are using it extensively. Then point cloud library, which is again a existing software framework for processing the 3D point cloud. Okay, 3D point cloud is the data coming from the depth cameras. Okay, so these are some of the popular software framework in order to program a robot. So these are some of the tools in order to simulate the robot. One of the important stage before the prototyping of the robot hardware is the simulation. Okay, during simulation we will get the exact idea of the robot working in a virtual environment. So Gazebo is a robot simulator. Okay, which is a free tool. We can use it for simulating the robot, and we will get an understanding about the robot behavior. And also there is OpenDrive, which is a framework for motion planning. Okay, so these are some of the tools. There are many tools available. I just picked a few. Then there are some simulators available like WebBots, which is again a better simulator. VREP. Okay, so these are some of the existing software simulators for simulating the robots. Okay, so these are some of the popular robotic programming languages. So C++, Python, Java, C#, MATLAB. Okay, so if you're working with ROS, I will prefer you to focus on C++ and Python, mostly on C++. Okay, yes. So you may be thinking why we need an operating system for a robot. Like you may be working on this kind of robot, simple robots like line follower robot, then obstacle detection robot. Okay, so in that robot, you may not be using a fully fledged computer, right? You may be using some logic circuits or microcontroller like Arduino, right? So in that, you are not using any kind of operating system, like you are not using Raspberry Pi or something. But in case of this kind of robot, like complex robots, these robots need some more computation, like it is having a lot of sensors, like camera, lidar, and a lot of actuators. So in this case, a a single microcontroller can't handle all the processing of the sensors and actuators. Okay, so in this case, we need a computer, fully fledged computer, and we need an operating system inside that. Okay, like maybe we will be mostly using Ubuntu, Linux, Debian mostly. Okay, yeah, and in case of real-time application, like if you take NASA rover, in those kind of application, we are using real-time operating system like QNX, VxWorks. Okay, so but in our common application, I think we can go with Ubuntu. Okay, yes. So let's start with ROS. So in order to start with ROS, you should have at least these things. Okay, like you should have understanding of Linux commands. Okay, I mean you have some understanding about on Ubuntu and its terminal commands. Okay, so terminal commands means like maybe I can show you that this is Ubuntu. I'm not sure how many of you work with Ubuntu. So like these kind of commands. Okay, so you should have some idea about this. Then programming knowledge in C++ or Python. Okay, I prefer C++ because all the functionality of ROS can be explored using the C++ APIs. Okay, and if you have these basic knowledge, you can start with ROS. Okay, so this is, I will say, mandatory. Otherwise, you will get stuck during the learning. Okay, it would be better if you have knowledge in Git, and if you have knowledge in Git, that would be a plus. Okay, so let's start with ROS. So let me share my experience in working with ROS. So this was one of the first project that I did in my bachelor's. So it's called a social robot, and I didn't use ROS. It's actually done in 2010. I didn't use ROS, but instead of that, I have used Python. Okay, Python TCP server in order to work with this robot. Okay, so I just included this robot to show the complexity of working with this robot. Okay, so this robot is having 2 cameras. You can see the eyes are cameras. Okay, and there are 12 RC servos. Then there are different capabilities of this robot. This robot is called social robot, meaning it can interact with people, then it can identify people, it can detect faces, so a lot of things like the things that is doing by Siri or Google Assistant. Okay, more than that, there is a face detection, motion detection, object detection. These kind of things are already there. So if we want to implement this kind of robot, can we do this using a simple microcontroller? No, right? We need some kind of processing, like in order to do the image processing, you should need a computer at least. Okay, so in this case, what I did was I used 2 laptops. Okay, so one laptop was running on Windows, which is doing the speech recognition, speech synthesis, then some sort of AI. It's basically pattern matching techniques. Using that, we are implementing basic intelligence. Okay, basic intelligence like chatbot behavior. Okay, and in the next laptop, I was doing all the image processing algorithm using OpenCV, and that was running on Linux, Ubuntu. So these 2 laptops has to communicate and exchange data, and also these are different programs. Like speech recognition is a different program, then face detection is an independent program, motion detection is again an independent program. Okay, so so maybe I can do everything in a single program, but that is too complicated. Okay, but if we do each program in a different code, then we can run it parallelly. But sometimes, most of the times, these program has to communicate with each other. Okay, for example, when the robot runs, in one laptop it is running speech recognition, AI, then communication to Arduino. In another laptop, there are 3 or 4 programs running in parallel, which is doing face detection and all. Okay, so these things has to communicate with each other, it should exchange some data in order to take some decision. Okay, so I have created a TCP server architecture. Okay, so each program will communicate with to the server, and server is taking the decision. Okay, so there is some inter-process communication, meaning communication between two or multiple programs. Okay, so this is how I implemented the software, okay, using server client architecture. Okay, so I just want to say I implemented a communication software. Okay, so I faced a lot of issues when I implemented everything from scratch, because the inter-process communication between two machines and two programs is actually difficult. Okay, to do it to do it if we want to implement inter-process communication nicely, then there is a lot of pain. Okay, so I faced a lot of issues with inter-process communication, then synchronization. Okay, so these are some of the challenges I faced without a project without using ROS, and this was one of the project with ROS. So this was the inter-process communication with ROS. Okay, so I show this project because using ROS you can do the inter-process communication easily. Okay, so so why we need this inter-process communication? Because if we work on a complex robot, then multiple programs are running, and these programs has to communicate with each other. Okay, so ROS is actually providing us with some functionalities in order to make this inter-process communication easier. Okay, so this is the core part of ROS. Okay, so you may be seeing some simulation, then some demos using ROS, but the fundamental or the core part of ROS is the communication. Okay, it actually helps us to create communication between multiple programs. Here you can see the ellipse is actually indicating programs running. Okay, the running programs are called process. So you can see there are a lot of process running, and these arrows indicates the communication. Okay, so communicating means it is actually exchanging some data. So communication means a process can receive some data and it can send some data. Okay, so you can see a graph of process here. Okay, like when you work with a multiple a complex robot, you may have to run maybe 20-30 programs at the same time. Okay, and these programs should able to communicate as well. So you will get a graph like this. Okay, so if you draw the diagram, you will get a graph like this, and basically in ROS it's called the computational graph. Okay, I will get back to that. Okay, so this project was like, it's called the chef bot. Basically the application was like delivering food. Okay, so it is actually having the abilities like autonomous navigation, meaning if we command the robot to go to some goal position, it will automatically go. Okay, so this is implemented using ROS. It's actually happened in 2013-14 time. So I have used the Python, C++, and it's completely running ROS. So using ROS, the inter-process communication is actually very easy. Then the synchronization and modularity, reuse of the code is actually very easy now. Okay, so this is the main part of using ROS. The inter-process communication, synchronization, modularity, reuse, these things we can implement these things very easily. Most importantly, you have to understand this. Okay, when anyone say about ROS, just understand. Think about the inter-process communication. Okay, that is the important part of ROS, core part of ROS. Okay, yes. So ROS is a software framework. Okay, maybe I can just show you the website. I think that will be good. Okay, so I'm just taking the website. So if you can go to ros.org, you can see the website of robot operating system. Okay, this is actually an open source framework for programming robots, and this is a website. And like any software framework, you can install this software framework in your computer. So as the name suggests, it's a robot operating system, right? So I also mentioned that it's not an operating system. So what is ROS? So ROS is a middleware, mainly communication middleware, and it needs a host operating system. Host operating system means Ubuntu, Windows. These are like the host operating system, and you can install ROS on this host operating system. Okay, so just understand that like this is not a real operating system, but it is having some features of the operating system. That's all. Okay, but we need a real operating system or the host operating system to work with ROS. Okay, so this is the latest version of ROS 1. There are two versions of ROS, ROS 1 and ROS 2. So you can find the ROS NITP. Okay, and in order to install ROS, maybe I can share yeah, maybe you can just take the website and you can find the install here. Okay, so the installation instructions is mentioned here. It's actually very simple. You can just copy paste into the terminal. Okay, there are a lot of tutorials available to show the installation instruction. So like just copy paste this command up to this. Okay, then you can able to install ROS on your computer. Okay, mainly I will suggest you to install Ubuntu. Okay, so if you're working with the latest ROS, that is NITP, it needs Ubuntu 20.04. Okay, so all things are mentioned in the website actually. Okay, so you can just go through it. Okay, so it's like 5-line instruction. Using this 5-line, you can install Ubuntu on your computer. Okay, yes. So that is ROS. It's actually a robotics middleware. It's not a real operating system, but it is having some features of the operating system. Like these message passing interface is actually our operating system is having that feature. Okay, so using ROS, we are getting that feature, and using this communication inter-process communication feature, you can write programs. Okay, for example, you are writing program A and program B, and these programs can able to communicate. Okay, I will show these things in the upcoming slides. Okay, so this is the latest version of ROS, that is ROS NITP. Okay, and the Ubuntu version that you need is 20.04. Okay, so these are the installation instructions. So after installation, you can just run a command called ROS core. Just make sure the installation is working fine. Okay, so if the installation is okay, then you can see the ROS core running. Okay, so after the installation, maybe I'm just going to the ROS equation. So this will give you more idea about what are the components of ROS. Okay, so as I mentioned, the important component of ROS is the inter-process communication. Okay, or the communication middleware, which helps the developers to create to create the programs that can able to communicate with each other. Okay, so this is the ROS equation that you can see from the ROS website. Okay, so these are the 4 important parts of ROS. Okay, so ROS is having these 4 parts. So the first part is the plumbing, second part is the tools, and third part is the capabilities, and fourth part the ecosystem. Okay, plumbing is simply means the inter-process communication. Okay, so the middleware, the communication middleware, using this we can able to establish communication between multiple programs. Okay, so that is the first part. And the tools are so I mentioned that in a complex robot, okay, we may have to run maybe multiple programs, maybe 10, 20 programs at the same time in a computer, and these programs have to able to communicate with each other. Okay, so while communicating, you may have to visualize some data. For example, one program is sending some image to another program. Okay, so you can visualize the data that is passing through the passing between these nodes. So these tools are actually helping us to display the data passing through different programs. Okay, also debugging. Okay, what is happening in this graph, communication graph. So using tools we can debug as well as visualize the data passing through data passing through the different nodes. Okay, I will show the details. Then the capabilities, again an interesting thing. For example, if you are planning to work with some high level stuff like autonomous navigation, meaning the robot can able to move A to B autonomously. If you want to implement these kind of capabilities, or like if you want to implement quickly the inverse kinematics, pick and place. Okay, so if you are planning to implement these kind of things, then ROS is having these capabilities, inbuilt capabilities. So using that, you can, simply customize it. Okay, simply customize it, and you can quickly prototype this application. Okay, so there are inbuilt capabilities in ROS. Okay, so you can simply use it, and so if you want to implement this autonomous navigation, those kind of stuff from scratch, it will take a lot of time. But using ROS, you can simply prototype it, okay, without taking much time. Then there is an ecosystem, meaning there are a lot of developers, there are a lot of websites available in ROS, related to ROS. So those websites will give you tutorials, then help like Stack Overflow. Okay, so there are answers.ros.org, a website which help you to you can put your question on that. Okay, so the ecosystem is that. So important part is the plumbing tools and capabilities. Ecosystem is just like the developers and all. So plumbing is the important part. Okay, so this is a thing, and I'm just showing how the interprocess communication works. Like you can see, here is a computer, and on the top of the computer we are installing the operating system, that is Ubuntu. Then on the top of the Ubuntu we are installing ROS. Okay, so using ROS functionality, we can write programs. Okay, and these programs can communicate with each other. Okay, communication means it can exchange data, different kind of data. For example, see, this is one of the example. Here one program is the camera driver program. Okay, so which is actually reading frames from the camera. Okay, and those frames are sending to another program called face detection program. Okay, so here this node is sending images to this program, and this program will receive these images, then do the face detection, and it is sending the centroid values of the face, okay, to this program. Okay, and this program will receive this centroid value, and it is controlling some Arduino board or something. So basically, using ROS, we can establish connection between different programs, okay, and exchange data. Okay, so these kind of programming, I'm not sure you have done these kind of programming before. Basically, we are only focusing on a single program, and we will do maybe some mathematical operations or some kind of processing, right? But these kind of communication programs, maybe you may not see this before, but using ROS, you can create these kind of programs. Okay, then let's see how ROS works. So you can see ROS is on the top of the operating system, and using ROS functions or ROS APIs, you can create robot applications. Okay, so ROS is having these three things, two things. So it is having the middleware, and the middleware, on the top of the middleware we have some client libraries. Okay, so using these client libraries you can program the robots. Okay, so basically what is happening is that these client libraries is giving APIs, okay, meaning functions that can be used in our programs. Okay, then that programs can able to communicate with each other. Okay, so the client libraries is the important part of ROS, which is giving programmers, APIs of ROS to the programmers. Okay, so if you get these APIs, you can use that APIs to communicate with each other. Okay, I'm not sure I mean, this may be can create confusion, but like you can just imagine, like in order to communicate with two programs, you can use these APIs, okay, ROS APIs, and you can able to communicate with each other. Okay, maybe when you see the demo, you will understand. Okay, okay, so this is the computational graph of ROS, meaning you can see there are 6-7 programs running on your computer. Okay, 6-7 programs running on your computer, and each programs are communicating with each other. You can see program 1 is communicating with program 2 and exchanging some data. Okay, so basically when multiple programs are running and if they are communicating with each other, they are creating a graph. Okay, graph like this. Okay, so this graph is called the computational graph. In ROS we are calling this is a computation graph. Okay, meaning multiple programs are running and they are exchanging data. Okay, so this is actually forming a graph called computation graph. So associating with this, I mean, there are different terminologies of ROS that is associating with this graph. Okay, so for example, I can say some terminologies, like program 2 is sending some data to program 5, right? And program 1 is receiving a data, I mean program 2 receiving data from program 1, right? So I will say program 2 is subscribing a data from program 1 and program 2 is publishing a data to program 5. Okay, so like subscribing and publishing, and we can see different terminologies of ROS using this computational graph. Okay, so let's see what are the different terminologies of ROS. Okay, I will not explain it in detail, but I can quickly go through each concept. Okay, so firstly, you can see different programs are running, right? And these programs are called ROS nodes. Okay, ROS nodes, and these are communicating with each other, right? So this is actually called a data bus. Okay, so when one program is communicating with each other, it's actually establishing a data bus like this. Okay, it's called ROS topic. Okay, and through this data bus we can send any kind of data. Okay, it may be string data, float data, or image, whatever. So that kind of data is called ROS message. Okay, then yeah, so these are some of the important terminologies associating with ROS. Okay, ROS nodes, ROS topic, ROS message. Okay, so these are some of the important terminologies. So let's see what is a ROS topic is. Like I mentioned that it's a data bus. Okay, this is one node and this is second node. So ROS topic is a data bus between two nodes, and through this data bus we can send any kind of messages. Okay, yes, so I'm just skipping, and let's see how this communication happening. Okay, in ROS. So maybe I can show through a demo. Okay, that will be good. So I just want to show you how two programs are communicating with each other in ROS. Okay, it's a very simple example. We can call it as a hello world of ROS. So initially we have to start a program called ROS master. Okay, so when you install ROS, you will get a command called ROS core. Okay, so when you run the ROS core, okay, when you run the ROS core, it is actually starting a program called master. Okay, and this master, the main purpose of the master is it's actually connecting between two programs. Okay, for example, if you check the purpose of matrimonial website, for example, it's actually connecting a boy and girl, right? Okay, similarly, the duty of the master is connecting two nodes. Okay, two nodes or multiple nodes. Okay, So in matrimonial side, the boy is having some requirements and girl is having some other requirements. And if these requirements are met, they will connect with each other. Okay. Similarly, the master is doing the same thing. If one program is sending one kind of data, and that same kind of data is needed by the another program, then they will get connected. Okay, so this is the brief idea about the application of the master. Okay, it will helps to connect between multiple nodes. So let's see how the master works. So I just started the master, and I'm just starting a program that is already available with ROS. Okay, it's like an example. It's called the talker. Okay, so the talker is running. Okay, and I'm starting another node called listener. So let's see what's happening with the listener. Okay, so we have run two programs, and let's see what is happening now. Okay, so this is what is happening now. Let's see, just a second. So this is the computational graph that I mentioned. Okay, you have I think you know the computational graph, meaning these are the programs currently running. Okay, we have run talker, listener. Okay, and what is happening is that talker is sending some message to the listener. Okay, so this chatter is the topic or the database. Okay, through this database we are sending a string data. Okay, so let's see what is happening in the topic database. So here is the topic, and you can see the data flowing through this topic. It's actually a string. Okay, so basically we have run two programs now. Okay, and these two programs are communicating with each other. Okay, talker is sending one data and listener is receiving it. Okay, and master is actually helping these programs to connect with each other. Okay, so this is the simplest communication in ROS. Okay, so the diagram of this communication is shown here. Okay, so we have the talker and listener. Okay, and when they start, they will inquire in master, and if there is a match, then master will send information for the connection. Okay, maybe you can think about the matrimonial site. Okay, so that is the analogy of this communication, like the master is doing the connection. So once they are connected, they can exchange the data between each other. Okay, so this is how the communication between two or more nodes happening in ROS. The master is the main person here. He is actually like exchanging the connection information between two or multiple nodes. Okay, connection information mainly these are connected. These two programs are connected using ports. Okay, I'm not sure you heard about ports, IP ports. So these master is responsible for the connection between multiple programs. Okay, so this is a basic idea of the ROS communication. Okay, so we have seen the talker and listener example. Okay, and so this is a basic communication. And so when you start with ROS, in order to learn various ROS concept, we have a tool called Turtle Sim. Okay, so if you take any ROS tutorials for beginners, you can see this Turtle Sim. Okay, which is very helpful to learn the basic ROS concepts. Okay, so for example, just a second, I can show you an example. I think it's turtle Tilio. Yes. So here you can see a GUI application, okay, and here I'm just controlling this robot using a turtle, keyboard. Okay, so you can see the turtle is moving. Okay, so you may be thinking why we need to use this. Okay, so I'm not sure you heard about a language called Logo. Okay, there is a programming language called Logo, this one. Okay, so this programming language is actually, maybe in your high school you may be learning this programming language. So the main use of this programming language is to understand, like, implement the logic. Okay, so if you just enter the command, the turtle will do the job. Okay, so by inspiring from Logo, here we have the turtle sim in ROS. Okay, the basic purpose is to understand the ROS concepts. Okay, I mentioned a few ROS concepts, but there are a list of ROS concepts available. Okay, so turtle sim is the perfect tool to understand how the ROS inter-process communication works. Okay, and we have seen ROS nodes, ROS topic, ROS messages. So you can explore all these things using turtle sim. Okay, so this is the turtle sim. Okay, you can work on the turtle sim to understand the ROS concepts. So for example, maybe I can show you the computational graph. So this is a computational graph. Just a second. You can see the turtle sim, that is, this one is a ROS program. Okay, and another ROS program is running here. This one, yeah, so this is another ROS program, I think. Yeah, this one. Okay, so there are two ROS programs here in the computation graph, turtle sim and teleop turtle. Okay, and it is having a data bus or ROS topic called turtle1/command velocity, and here the arrow is from teleop turtle to the turtle sim, right? So we will say teleop turtle is publishing a topic called turtle1 command velocity. Okay, and turtle sim is subscribing the same topic. Okay, so if you just see the data through this data bus, you can see this data. Let me show you that. So if I'm just moving the arrow key, you can see the data. The main data is linear and angular velocity. Okay, so this is the data that is going through this data bus or ROS topic. Okay, yes. So that is the turtle sim. Okay, so now I'm just showing a simple example. So how can we use the ROS concepts in a real robot? Okay, so these all are abstract concepts. I'm pretty sure that you will not get all the concept of ROS in a single session, but I'm just showing how to apply these ROS concepts in a real robot. Okay, so you may be seeing this simple robot maybe in your project expo. Okay, so I just created a ROS interface for this robot, and you can see it's a mobile robot, and this is the simple circuit. Okay, so you can see there are two motors. Okay, and there are some encoders, wheel encoders. So this is the circuit in order to work with this robot. Like, it is having a motor driver, then the motor driver is controlling through the Arduino Mega. Okay, and we have the left and right motors, and on the left and right motors we have the encoders, which is again connected to the Mega. Okay, and there is an ultrasonic sensors, and there is also a Bluetooth module. So this is a simple circuit, and this is the actual prototype. Okay, it's actually like quite messy, but you can find the Arduino Mega is there, then motor driver, ultrasonic sensor, Bluetooth module, all the things are here. So in order to control this robot using ROS, what I did was I have a Bluetooth module, right? So I connected this Bluetooth uh, to my laptop. Okay, so now I can send commands to this robot via Bluetooth. Okay, so in the robot side, we have this much of things, and the robot is connected to my PC through Bluetooth. Okay, and in the PC side, I have these programs. Okay, so these blocks are the programs. There is a Bluetooth driver, twist to motors node, teleop node, diff to TF, dead reckoning. Don't confuse with these terms, but I'm just showing these are some programs in ROS which can communicate with the Bluetooth. Okay, then it can send the linear and angular velocity to the robot, so that the robot will move in such a way that if there is only linear movement, it will move straight. If there is angular movement, then it will rotate. If there is linear and angular movement, it will move in a circle like that. Okay, so these things on the right side, these things are ROS nodes. Okay, so you can see these ROS nodes are communicating, like the twist to motor node, meaning this node is converting the linear and angular velocity to motor speed, and that is actually sending to the robot, okay, through the Bluetooth. Okay, and from the Bluetooth we are receiving the encoder values, so that is actually converting to the odometry, meaning how much distance is traveled. Okay, so this is a simple explanation or simple example of how we can interface a simple robot to ROS. Okay, so mainly you can see the inter-process communication. There are 5 programs here, and each program are doing a different job, and these programs are communicating with each other and sending different data. Okay, so that is the main essence of this example. Okay, it's showing we can do the entire processing or entire application with different programs, and using ROS you can send data between different programs. Okay, instead of implementing everything in a single program, we can implement in multiple programs, and you can communicate with each other. Okay, yes. Okay, so these are the basic idea. Okay, and now we are just quickly going through the list of tools in ROS. Maybe I can show you with some demos. That would be good. Okay, maybe I can switch to the demo so you will get an understanding. Okay, yes, that will be good. So let's switch to a demo, and I will explain the tools of robots, tools of ROS and the various capabilities. Okay, so as the ROS equation says, the main part of the ROS is the inter-process communication, then the tools, then the capabilities. Okay, so now I'm just showing a demo. Okay, so which will show you set of tools and the capabilities. Okay, so let's see the Husky demo. I think this one will be good. Let me check. So I'm just showing a simulation in a tool called Gazebo. Okay, so you can able to see a robot called MIR. Okay, so this is the robot. Okay, and this is actually using in warehouses. Okay, now what I'm trying to show you is that just a second. Okay, so we have the simulation running here, and you can able to see the environment. Okay, so this is a simulation environment. Okay, so actually this is a pretty big demo, but I can explain the various things that is mentioned. Okay. Okay. Yes. Okay. So guys, you can able to see the robot here. Okay. So in this demo, what I'm trying to show you is that the autonomous navigation of a robot. Okay, using ROS. Okay, so I mentioned that there are three important parts in ROS. That is the plumbing, that is inter-process communication, and next is the tools, next is the capabilities. Okay, so you can see a tool in ROS here. Okay, this is called RVs. Okay, so this is actually a tool in order to visualize. Okay, visualize the robot data. So here you can see the visualization of robot map, okay, as well as the robot model itself. Okay, so this is one of the tool in ROS. Okay, and this is RQT, which is again a tool in ROS, which is mainly used for controlling and debugging. Okay, so this is actually the tools in ROS, which is able to visualize and debug. And here I am showing the capability of ROS. Okay, so you can see I'm giving a goal position here. Okay, so wait for some seconds. Can able to see it's actually path planning. Path planning means it's actually finding a shortest path between A to B, and it's moving to that goal position. Okay, so this capability is already inbuilt in ROS. Okay, so if you are planning to create a robot, maybe a mobile robot, you can customize the ROS navigation stack. Okay, so using that you can implement this kind of behavior. Okay, okay, so this is the autonomous navigation. Okay, so if I give a goal position here, you can see it's actually path planning. It will take some time to path plan, I guess. Yeah, you can see a long path here, and as I mentioned, RVC is just for visualization of the robot parameters, and in Gazebo, this is a simulation, right? So simulation is actually simulating the robot in a virtual environment. Okay, so you can see the robot working without the actual hardware. Okay, so you can find robot is working smoothly. So yeah, it's actually moving through this door. We are not controlling it. It's all autonomous. Okay, so these kind of capabilities are inbuilt in ROS. Okay, so you can customize it, and you can include these capabilities in your robot. Okay, and most importantly, just a second. Let me show you the RQT graph, meaning the computational graph. So all these things, when you do all these things on the background, there are a lot of programs are communicating with each other. Okay, so this is the computational graph currently. So you can see a lot of programs here. Okay, and these programs are communicating with each other. Okay, there are ROS topics, different ROS topics, and this is how all are communicating. Okay, so you can see the complexity of the communication. See, this is how the communication graph or the computation graph. Okay, so I think you may understand the requirement of the inter-process communication. Okay, so when you do complex application, you may have to run multiple programs, and these multiple programs have to communicate with each other and exchange data. Okay, so ROS is a framework which will help you to program your robots with the help of this inter-process communication. Okay, so this is an example of autonomous navigation. Let's see an example of pick and place or inverse kinematics. So let me close all this stuff. And I'm not sure you heard about the UR5, Universal Robot. So let me show you the simulation of Universal Robot. Okay. Okay. I'm not sure it is working fine, but let's see. Okay, I think there are some issues. Yeah. Let me close it and take it again. Yeah, I think currently it's working. So this is a robotic arm called Universal Robotic Arm. Okay, so let's see how to work with this robotic arm using ROS. Okay, so in order to work with a robotic arm, I'm not sure you heard about the inverse kinematics algorithms and all. So you have to implement those algorithms to move the end effector of the robotic arm. Okay, so using ROS, what you can do is there are some capabilities in ROS. Okay, you can simply use it and you can implement these kind of motion planning in ROS very quickly. Okay, without writing everything from scratch. So you can see how we can move the robot end effector. So I just move the end effector, and you can see the gazebo. The simulation is like this. I'm just try to move the simulation to this pose. You can see it's actually moved. Okay, so this is an example of the motion planning. I can put the robot here and do the plan and execute. The robot will move like this. Okay, yes, so let's check the RQT graph again. Let's see what is happening in the background. Okay. Okay, it will take some time. Yeah, so this is the RQT graph. Okay, so you can see it's a big graph and there are a lot of nodes. A lot of nodes are communicating with each other. It looks complicated, right? Yes. So this is what happening in ROS. Okay, so you are writing many programs and these programs are communicating with each other. Okay, and the middleware, the communication middleware, is the core part of ROS. Okay, and all the things, the things that you are seeing, these capabilities and everything is built on the top of this communication middleware. Okay, yes, so that was the demo, and I'm just skipping these things. These are available online, like who created ROS. It's actually like there's a company called Willow Garage in ROS, in US. So they actually created ROS framework. They developed ROS from 2008 to 2013. After that, it is maintaining by Open Robotics. Okay, So this is the core team of Open Robotics. These guys are developing ROS and Gazebo now. Okay, and ROS, in ROS there are some distributions, meaning like in Ubuntu we have Ubuntu 16.04, 18.04, like that, right? So in ROS also there are distribution. So you can able to see some distribution like ROS Indigo, Kinetic, then Luna. So you can see the year and the name. So the latest version is NITP, okay, and ROS 2 is also there, which is like an upgraded version of ROS 1. So the latest version is ROS 2 is ROS 2 Foxy, okay, and there are a lot of robots supporting ROS, meaning the entire control of that robot is running using ROS. So there are different robots working using ROS like PR2, Turtleboard. Maybe this robot may be familiar to you. So these robots are controlling entirely using ROS. Okay, so these are some of the examples. And also some manipulators like this are also controlled using ROS. And there are a lot of demos available in YouTube. You can see you can just mention about ROS robot demos. You can find tons of videos. Okay, and these are some of the sensors that is supporting ROS. And also you can able to interface the Arduino board to ROS. So yes, and most importantly, I just want to show you which all the companies are using ROS and what will you get if you become a ROS developer. So basically, most of the companies are working with ROS, but may not be extensively, but they have an R&D wing. They are working with robotics, and most of the companies are working using ROS. Okay, you can find some of the companies from the list, and this is not this is very short list, but you can find a lot of companies are using ROS for their research and product development. Okay, so ROS is using by robotics researchers, students, then professionals, companies, then hobbyists. So these kind of people are using ROS, and there are a lot of opportunities for ROS developers now. You can just simply search for ROS developers opportunity. You can find tons of requirements, mainly in US, but in India also a lot of startups are popping up. So I'm seeing a lot of opportunity for ROS in India as well. It's actually coming, okay? And so for the future scope, so what will you get if you learn ROS? The thing is that there is a chance for employment. You will get job, and also if you have a robot, then the capability of the robot can be we can implement various capabilities of robots using the software. Okay, so software is the key, right? Like for the computer software, robot software is an important part. Okay, so if you have a robot, the capabilities can be improved using the software. So ROS is one of the framework which we can use to implement robot software. Okay, and it's actually becoming a standard. You can find a lot of companies, a lot of robots are currently using ROS. Okay, and even if you're planning to go to do an MS or something, most of the research labs are using ROS for robot programming. Okay, so knowing ROS will be a plus. Okay, and there is ROSCon, annual ROS conference, and this was taken during ROSCon, one of my book release. Yes, I have included some demos, but this is available in YouTube. Okay, yes, and there are some interesting demos like using Turtle Sim. Okay, drawing Iron Man. So these all projects are done in my course actually. The students in my course. This is ping pong game in Turtle Sim. Okay. Yes. Okay. So that's it. So finally, I just want to show you my course, developer learning path. So currently, I am running a course called ROS Developer Learning Path. It's actually a big course. So basically teaching ROS from the basics to the advanced concepts. Okay. Yes. So now it's a time for Q&A. So you can ask questions or you can just put the comment. I think, yeah, you can put the comments, the comment box. Yeah, I think there are some comments here. Let me address it. Yes, I'm just going through the comment. Just a second. Yes. Okay. So the first question is, what type of sensor I use for autonomous navigation? Here ROS is facilitating communication with. Okay, so mainly the it's asked by Neela Dubey. So the main sensors are the depth sensors or laser scanners, lidars like RP lidars or something. You can use it for autonomous navigation. Okay. Then when you're saying autonomous navigation is inbuilt in ROS, does it means, is it like any existing library? Yeah. So inbuilt means a template of the autonomous navigation stack is available in ROS. Okay. So you have to customize it. Okay. But you don't need to implement it from scratch. Okay. But you can customize these packages. Okay. In ROS, and you can deploy it. Okay. So I mean, for any robots, you have to do the customization. That is the work that we have to do. Okay. Yes. Yes. And yeah, thank you. Okay. So we are new to ROS, unable to get so much new. Okay, if we could get this presentation. Okay, yeah, maybe I will try to share the presentation. Okay. Okay. Yes, thanks for. Okay. Yes. So if you have any other question, just put it in the comment. Okay. Yes. Yes, maybe I can take 5 more minutes. So you can. Actually, the problem is that this is a very, very big topic. Okay, so it's very difficult to say the concept, at least the important concept in 1 hour. It's very difficult. So I am also like struggling because even I know the concept, it's very difficult to present in this very limited time span. Okay, so please understand that. I maybe like I may be, you may feel I'm very fast in presentation, but the thing is that there are a lot of contents. Okay, that is a problem. So maybe I can share the slides with you, maybe some part of the slide. Okay, so you can just go through it, and this is just an abstract concept of ROS. Okay, because just understand the magnitude of this topic. I'm actually running a course which is, I mean, time span of the course is like around 1 year. Okay, so just understand this topic is very, very I mean, very, very big. Okay, so that's what. So this is just an abstract. I think I could give an idea about, like, there is a framework called ROS, and we can use it for robot programming, and there are some concepts associated with it, and we can do some application using it, and you can install it on Ubuntu. So basic stuff. I'm not expecting much things. Just understand this basic stuff, and you can develop it further. There are books, there are courses, there are a lot of YouTube tutorials available. Okay. Yes. So one question. What are the prerequisites for learning ROS? So, yeah, so I think I have mentioned that in one of the slide. Basically, you should have understanding about Ubuntu, okay, and Ubuntu commands. Then C++ or Python. I will prefer C++ knowledge, mainly the object-oriented concept. Then I think Git. If you know Git, it will be a plus. Okay, so these things are the basic things you need to know before starting working with ROS. Otherwise, you will stuck for sure. Okay, so one question from Nigel. ROS need a host OS like Ubuntu, which comes with a cost of being not so friendly to all. Why don't we have a GUI application similar to ROS communication different components in robots? That's actually a good question. So currently ROS supports Ubuntu. Then there is a Windows port also, and it will work on Mac also. So it's not like a software. Okay, it's not like a software. It's like a framework, and the purpose of this framework is that this framework will give you some functionalities. Okay, some functionalities, and we can use those functionalities in our program. Okay, so we can use those functionality in our program and make our programs in the we can use those functionality in our program, and these programs can communicate with each other. Okay, so we can't implement all the things of ROS in a GUI. I think there are some implementation of ROS, like in order to get in order to get access to the important part of ROS, there are some GUI using, like, for example, RQT. Maybe I can show you that. This is actually a software in ROS, okay, which is having plugins. Okay, so if you want to add something, you can add it here. Okay, so there are GUIs available. Okay, but mostly we are using the command line interface. Okay, yes. Okay, yes. So okay, so prerequisite is I mentioned this, and another question is, growth of robotics at our college level is limited. Can you suggest some community or group we can be a part associated with, so that we can explore more? Okay, yeah. So regarding the community, I think yeah, so there are a lot of communities available in robotics. There are a lot of communities available. Maybe I can share some links, but I prefer. I mean, what will I say? Like, there are a lot of books available. There are a lot of courses online available. So maybe some of you can explore these things and share with others. That will be good, because in most of the colleges, there may be some people who know ROS, OpenCV and all, and after maybe 4 years they will go. Okay, so there will not be any knowledge transfer happen. So mostly in my colleges and all, in my college and some of my friends' college, what they are doing is that they have some experts in ROS or OpenCV, and they will share, they will arrange workshops. Okay, and the knowledge transfer will happen. Okay, so maybe in your group, maybe some guys can come up and try to acquire knowledge in ROS and share with others. Okay, that will be good. Okay, maybe I can share some links of some groups so that you can work with robotics, ROS, etc. Okay, so what will be the course duration? Yeah, it's actually like, it's my course is having 4 modules. The first module is ROS for beginners, then mastering ROS, the ROS advanced, and becoming a ROS developer. It's actually a paid course, and I am also enrolling with these individual modules also. But for beginners, ROS for beginners module will be the must, because that module is only giving the basic stuff. Okay, the basic stuff is the important one. Yes. Okay, so suggestion of projects which involve ROS. So commonly people are doing these autonomous robots. That is quite popular. If you just search for autonomous mobile robot using ROS, you will get tons of projects. Okay, there are a lot of projects using ROS and yeah, there are a lot of projects using this. So this is one thing, that autonomous mobile robot. And you can also work with the manipulator and implement this motion planning. Okay, so basically, if you can explore the capabilities of ROS, you can do a lot of projects. Okay. Yeah, so we are in the third year, and it's a good time to start with ROS for projects. Yeah, so learning ROS will take some time for sure. Okay, and it's not easy. So you can just start. Okay, just start, and there are a lot of free tutorials, free books available. So you can start exploring, and for doing this autonomous robots and all, it will take a lot of time. Okay, because you need to understand the ROS concept. Then only you can start customizing these packages and all. Okay. Yes. So I will share some links to proceed, and most importantly, the wiki.ros is a better website, I will say. But the problem is, yeah, it's difficult to start with wiki because it's very similar to the Wikipedia. Okay, if you are reading something from the Wikipedia, you will maybe direct you to another link. Okay, so all things are here in the wiki.ros.org, but only few people can decode it. Okay, then there are books. So I'm not sure if you are like just go through these titles. Maybe there are some free books also available. So maybe I can share a link of a free book so that you can explore that. And if you are a beginner, I will prefer this book also, Robot Operating System for Absolute Beginners. Okay. Yes. Okay, then so we can conclude. Okay, so thanks for inviting me. Okay, I will share the slide and I will share some links also. Okay. Okay then, guys.
So that concludes our third and the final speaker session. So thank you, sir, for giving detailed information on the ROS. I hope the
Yes.
viewers got to know about ROS, which is one of the cutting edge technology in robotics. And I think this session was a full package for a robotic enthusiast. Plus, we at Robotics Club, we have been working on integrating small scale robots with AI, and hope this session would have motivated a lot of us in working in that domain as well. And for those who ask their queries, I hope their doubts got resolved. So I'm thankful to Lentin Joseph, sir, for giving such an informative session. Thank you so much, sir.
Thanks for inviting me. Thanks. Yeah. Okay then. So I'm just leaving this. Bye everyone.
Bye, sir.
Bye.
So that was Lentin Joseph, sir. I hope you guys enjoyed it. And for those who are new to this YouTube channel, please subscribe to this and like and follow all our social media pages. And I'm thankful to all of you for giving us such a huge amount of participation in our Abhiyuthhan event. So thank you, everyone. Have a nice day to all.